Okay, Jordan, would you scoot over just a little bit to the right? Everyone back here, if you cannot see clearly the screen, actually just, why don't you go ahead and move up to these. Move up closer. We're going to go through this again because some people seem to continue to have difficulty with these concepts. It's absolutely critical that you understand them. Because if you don't, you're going to be lost the rest of the year. Come on. There we go. All right, your homework assignment, which was only on the video, or only in the lecture part for a reason, was to design a network with multiple routes. And the first thing you need to understand, didn't I say go ahead and move up here, guys? You guys back there in the back. The thing you need to remember and understand is every network interface requires an IP address, subnet mask, and a default gateway. Okay? Every device needs one of those. One big rule that many of you forgot is when you are on the private side of a network that connects to the internet, when you're on the private side or the protected side or the safe side of a firewall or a router, then you should use what for your addressing? Yes? Private IP addressing, right? And there are only a few ranges that meet those criteria. First one is what? Give me a range of IP addresses, Austin.
Oh, the range, I was going to give you the next class A, B, or C. What was that?
Give me a network range of IP addresses that are considered private.
I guess A, B, C, 10 would be, yeah. Then it would be what, 1.
That's good, Austin. Thank you. Next, Quentin.
172.16.
Subnet mask. 16-bit subnet mask. Okay, we're good, Austin. 255.255.0.0, right? What's the subnet mask for the 10 series network? Awesome. I want other people to participate, all right, buddy? All right, give me another range, another private IP address range. Aaron.
192.168. Anywhere up to 255.
24-bit sub. These are the IP address ranges. So for 10 series, you could have 10.1, 10.2, 10.3, whatever you want. All of those would actually be on the same network because it's an 8-bit subnet mask, right? Everybody follow that? And the thing to remember as you're going through this, and you really need, just out of curiosity, how many of you are required to take notes in your other classes? In other classes besides this, how many are required to take notes? Just a handful, okay, maybe a third of you. When we're doing an exercise like this, it's more important that you grasp the concepts than it is for you to take notes, because what we're going to take is not necessarily, or what we're going to do is not necessarily repetition or not necessarily memory, okay, memorizing it. You need to understand the concepts, okay? So, I mean, absolutely, if you need to take notes, but otherwise I'd prefer that you just kind of focus in on the concept, because once the light goes on, you'll get it, you'll understand it. But if you try to refer back to your notes all the time, then you may not. So just kind of watch the concept. All right, so let me get rid of these. So these are the private IP addresses up here. You always want to use those on the inside of your network, on the inside of the firewall. Now, if your firewall is connecting two private networks, give me a scenario where your firewall would connect two private networks. Give me a business scenario, Miguel. Again, this is another example of why I want you to listen to me and pay attention to this instead of taking notes all the time. Miguel, give me a scenario where you would have a firewall that separates two private networks. Give me a business scenario or an educational scenario or some situation where a real life application of two private networks. No? No idea? Okay. Yes.
So if you would connect the Plymouth High School with like Lincoln,
PHS or any one of our schools, right?
Lincoln Elementary.
And you've got Lincoln Junior High, and nobody's connected to the internet. This would be one firewall. Oh my goodness. One firewall in between them. Or, what's another name for the firewall in most cases? Christopher? What's another name for a firewall? Not a switch, but a router. Very good. Okay. You've got a router in between. On this side, you would have a private network, and on this side, you would have a private network. Okay, now, Brittany, give me two ranges of IP addresses that would work in this scenario. A PHS side and on the Lincoln side. What's that? Two private ones. Give me a range. .11.20 for some IP address over here. How about on the other side of that router? Very good. 192.168.2.0. Okay. Those are the network addresses over here. Actually, this should probably be, if I'm going to use 10, it's going to be 0.0.0 as the network address, because it's an 8-bit subnet mask. The thing that I want to point out is this network, because it's on the other side of a firewall, is different from this network, right? Two different network ranges. If I have the same network address on both sides, then the router isn't routing, okay? And it's not going to do the job. We're not going to be able to send packets from here to here. Why? Because if this PC over here, now this is a very, very, very important concept. You have to understand this and you have to think through it. Sometimes it's necessary to just kind of picture it in your mind. If this PC logs into or goes to a website or needs to attach or access the files on a PC on this side, okay, or a server or any other device on this side, maybe it's a printer, it's going to form a packet. And that packet, in the context of what we're talking about here, Jordan, in the context of what we're talking about here, that packet is going to have two things that are important. What are those two things? If it needs to be able to send data, if that packet is going to have two things. What's it going to have? If it wants to know where to send that packet, what's it going to have? What's it called? Of what? What's that name called? IP address of what? It will have that, but every packet you have that's on a network has two things that are important to remember. Yes, they are IP addresses, but what are they called within the packet? What are they called within the packet? Okay, let me give you another hint. We have where it's coming from and where it's going to. What's the name in IT terms for where it's coming from. What's that called? Larry?
The host.
Host, but there's another name. Write these down. These you should take notes on. You have a source. If this PC here has a packet here, it's going to have a source. And if that source is this PC, then the source address is going to be 10.0.0.5, or whatever that IP address is of that packet. It's going to have a source, and that packet has to have a what? What's the second thing, Quentin? Destination, thank you. And in this particular case, what is the destination address going to be? Jessica? I can't hear you. No, that's the source. We're talking about this one. So the destination is going to be 192.168.2. Probably 5 or 6 or 7 or 8 or something, 1 through 254, right? So this packet is going to have a source and it's going to have a destination. Every packet that's sent on the network has a source, which is where it's coming from, and a destination. If that packet that's created, pay attention to this. If this PC creates a packet, it's going to look at its source, it's going to look at its own network. What's the network address for the source? Quinn. The source network is 10.0.0.0. Then that PC looks at the destination for that packet. And what is the network address for that destination, Miguel? One I just circled. Huh? I can't hear you. Yes, this PC, but what is the network address for that IP address? 24-bit subnet mask. So what's the network address? Does everybody understand what I'm asking? What's the network address?
192.168.2.0.
Very good. 192.168.2.0, because it's a 24-bit subnet mask. Okay, Miguel, I'll give you another one. If the destination is 192.168.3.4 with a 24-bit subnet mask, what is the subnet mask, not 24-bit, but what is the actual subnet mask that I would assign to that IP address if it's 24-bit? That would be a 16-bit. Each one of these is 8 bits, right? So what would it be? 8 plus 8 is 16 plus 8 is 255.255.255.0. That's a subnet mask. And if that's the subnet mask of this IP address, then what, pay attention to the drawing up there, then what is the network address of that subnet, or of that IP address? What is the network address? When I want to know what the network address is, or the PC wants to look at the network, or wants to know what the network address, then it compares the subnet mask to the IP address and says where the ones end, which in this case is 255, 255, 255.0, where the ones end, the network address ends. So what is the network address for this, Miguel? Where the ones end. So it would include this, plus this, plus this, and then you put a 0 at the end. So what is the network address? That's it. Okay? All right, one more time. So I'm not taking anything for granted with any of you. And that is, if I have an IP address of 192.168.4.5, Miguel, 192.168.4.5, and my subnet mask is a 24-bit subnet mask, what is the network address for that IP address? Very good. Okay? One more time. If I have an IP address of 172.16.3.75, Quentin, what is the network address of that IP address if I have a 16-bit subnet?
172.16.0.0.
Very good. 172.16.0.0. Okay, back to my earlier, everybody pay attention. Back to my, come on. Back to my earlier question, or the earlier point. When this PC wants to send a packet to this PC, it first looks at its own IP address, finds out the network address. Once it finds out the network address, and in this particular case, if the source is 10.0.0.0 network address, and the destination is, what's the destination network address for this? Yes, Austin?
192.168.0.0.
Very good, because it's a 24-bit subnet mask. So you take off the 5 there, that's the destination. Okay, it's going to look at that packet, and it's going to say, hey, this packet is not going to my network, therefore I need to send it someplace else. So what's the first decision that PC networking component makes? I need to send it someplace else. Yes? I can't hear you. Maybe. When would it not, you're right most of the time, when would it not send it to the gateway? Austin, Howell. When would it not send it to the gateway? All right, who else knows? Besides Austin, Shamus. Yes? If there's another routing statement. Oh my. If there's another routing statement in its configuration. How does this routing statement get created? How does this routing statement get created? Christopher. Gabe. How does the routing statement get created? This is in your reading material, and we just talked about it on Tuesday. How many know, by show of hands, how many of you know how a routing statement gets created in a computer's configuration? Jill, do you not know? Christopher, or Johnny, do you know? Jordan, do you know? Josh has his hand up. Okay. Guys, this is a, okay, put your hands down. This is a big part of the reading, okay? This is probably a half hour of what I lectured on Tuesday. Routing statements are created by you as a network administrator. Does anyone know the syntax? There's a word that I used on Tuesday. Quinn, what is the word, what is the syntax for adding a routing statement? Wait, time out. Where do you add the routing statement? How do you do it? Michael. From the command prompt, which is this entire chapter, using IP from the command prompt, okay, or manipulating IP. So, from the command prompt, does anyone recall how you add a routing statement? How do you view the routing table on the computer? How many know that? If you don't know that, you haven't read the material. You haven't even touched it. You haven't listened to my lecture on Tuesday. You haven't read the material. You've just been sitting there like a slug, assuming that you were here on Tuesday. So you need to get nervous if you don't know that. Okay? The syntax is route space print, enter. We all did it in class on Tuesday. Route space print from the command prompt tells you what the routing table is on your computer. Okay? If you want to add a routing statement to it, the syntax, or the way you type it, is route space add. Route space add. Now, all of those of you who are already typing probably already have it in your notes. But you need to actually focus on it and think about it. So, route space add adds a routing statement. All right, so if that computer does not have a routing statement that tells it to go to a different interface or a different destination, then it's going to send it to its gateway, as someone over here already said. Okay, given our drawing here, where is the gateway? Josh, on that firewall, the gateway for this PC is this interface on the router. And that interface on the router has three components that you configured, Larry. What are they? Every host on a network has three things.
IP address.
IP address,
Subnet mask.
subnet mask. Now, what's the importance of the subnet mask, Jill? Yeah, what's the importance of it? What's its use? No? You have to have the subnet mask, otherwise it can't communicate. But the importance of the subnet mask is that it tells you what part or what your network address is. Because when you compare the subnet mask to the IP address, just like we did over here, okay? When you compare the IP address to the subnet mask, it tells you what your network address is. All right. So the first component of this interface is the IP address. Second component is the subnet mask. Third component of this interface IP configuration is what, again, Larry?
It is the gateway.
Is the gateway. Now, here's the question, magic question. A lot of you seem to keep forgetting. Zach, what would the default gateway of this interface be on that router? If that router has only two interfaces and one of them is here, this interface has to have a default gateway. If you were going to configure this, what would it be?
Would it start with like 192 or?
It would, exactly, because this interface has a network address of 10.0.0.0. The other interface, which is over here, has a network interface, or has a network address of 192.168.2.0. So this IP address is going to have three components. Christopher, what are those three components?
Subnet mask.
It's going to have a subnet mask, and the subnet mask for this interface, we'll start with the first component though.
The
IP address. What's the IP address on this interface going to be?
32.168.
I think that's a 2 dot, give me something. 5. Okay, what's the subnet mask going to be?
255.255.0.
Very good. Okay, now what is the gateway? Boy, there's not going to be a gateway because we're not connecting any of them. There's going to be a gateway on that also. If this firewall in place, what do you think the gateway address would be for that firewall? Or for that IP address on the firewall? Anyone have any idea? Michael? Yeah, probably not. It would be some other router that's over here. If there is no other router on this network, there would be no default gateway. If there's no default gateway, or if there's no other router on this network besides this one would not have, well, you know what? You're actually right. It would have to be. It would have to be this one if there's no other router. So this interface would have a default gateway of this guy. This interface would have a default gateway of that guy. Now, what a mess this is. So let's just get rid of everything. Better yet. Delete. Add. All right. Oh, sorry, Jessica. I'm adding these pages to yours. Let's put it up somewhere else. How about there? Add page. Pay attention to the drawing. Now that we've gone through all of this, and I know that all of you guys paid attention, right? All of you paid attention. Because if you don't, I'm gonna go commit harakiri. I've got, give me a scenario where I would have two private networks besides Lincoln and Plymouth High School. Yes? Besides the school. Somewhere besides the school. And from someone other than those who have answered questions today. Okay, Tex, help me out.
Walmart and Sam's Club.
Oh my God. Well, yeah, they're, you know what? That's a great example. That's a business example of two businesses that are entirely different locations that are part of the same overall organization. Very good. So we have Walmart over here, and we have Sam's Club over here. And they're connected by a fiber network. So over here at Walmart, I have a cash register, which is a PC. I have a printer, which is also an IP address. And I have a switch. Now what is it going to, tell me what I'm going to have over at Sam's Club. Austin, give me one device.
Someone using their phone on their Wi-Fi.
Okay, so they've got a phone, which is going to have an IP address. Give me something else, Jordan. Got to sound off, I can't hear you. A PC, another PC. Okay? And these guys need to talk to each other. So you're building this network from scratch, Aaron. What am I going to need in between Walmart and Sam's Club in order to be able to communicate? Huh? At least one router, right? Where am I going to put it? On the Walmart side? Okay. This is a router. How many interfaces is that router? How many network interface cards is that router going to have? 8? 8? All right, so we got lots of locations. Let's not do 8. How about 2? We have one interface there, and we have, well, what's that router going to connect to? It's got a fiber interface, or a fiber connection between the two. Miguel, what's this router going to connect to? What am I missing in this drawing? Well, it is connected kind of to a PC through this switch, but we're missing something on the Sam's Club side. What are we missing? Okay, we could have a server there. Actually, I'm glad you brought that up, because that was another mistake that some of you made. What else? But there's one component that's keeping me from connecting Walmart to Sam's Club. What is that?
Firewall.
Well, we can call this router a firewall, but where would that firewall, if I put another router in there, where would it be? Okay, so we'll put another router in here. Because the Sam's Club people don't trust the Walmart people, but they still need to communicate. Okay, kind of like our government. Congress doesn't trust the president, who doesn't trust the, right? So we've got to maintain some firewall between them. What else am I, no. This is not the time for humor, awesome. Okay, what else? Are these phone, is this phone and this PC and the server going to connect directly to this router? What else, Miguel? What else do I want? Come on. Is there going to be something between the router and these devices over here on the right? How do they physically connect? Think about first chapter. How do they physically connect? Layer 1. Could be, this guy's going to be Wi-Fi. So in between, there's probably an access point. How about this PC and this server? How's it connected? There's something between the router and these devices that we're probably going to use. No idea? Frank?
Switch.
Thank you. We're gonna have a switch, all right? We're gonna have a switch. Do you understand what we're saying now? Okay, so let's say the phone has a cable connected to it. Let's say the PC has a cable connected to it, and the server has a cable connected. This router is going to talk to this router is going to talk to, or is going to connect to that switch so it can talk to all three of these devices. So what do I need on the left side, Zach? What am I missing?
Server.
Could, we'll put a server there. Oops. What else?
Wires.
Thank you. Very simple. You'd be surprised. People forget about that stuff. Okay? All right, so I've got all, what a network. Now, there's one thing that's probably missing off of this. There's one thing missing from this. Chances are Walmart and Sam's Club are also going to connect to another giant network. What's that going to be? Yes? Awesome. The internet. Okay? If you were going to configure this, how would you configure the internet on this? Jill. Could have the internet in the middle, because they're both going to be communicating. And what were you saying? Ooh. Now there's an interesting concept. If I had them right between, so each of these routers, now wait a minute, you're right, that's probably how it's going to be configured. Each of these routers is going to connect to the internet somehow, and then between the two networks, if they're using the internet as their connection instead of a direct fiber connection, what are they going to need to have between the two networks? Yes? Huh?
Public addresses.
They are going to have public addresses. Show me where a public address would be. Okay, so this would be a public address. Where else? And this would be a public address. Now, if I'm passing packets on this network, goodness gracious, to this network, through the internet, what's the one component that we're missing that we're going to do? We're going to want to do. Yes? Well, yeah, we've got an ISP router up here and up here. There's something else. Am I just going to, yes, Jessica? Huh? Yep, got a DNS, absolutely. You're all right in all these questions. But am I going to send my packets directly through the internet? Maybe it's Social Security. Easy, easy, easy. I want everybody else to kind of think about this too. Am I going to send my packets directly through the internet if they are Social Security numbers, Christopher? Why not? Right, because Gabe is out here, oh, for goodness sake, with a packet sniffer. Hold on, we'll figure out how to do this. Don't talk about it. Okay, because Gabe is out here on the internet sniffing packets. That's what he does. He's trying to get somebody's Social Security number so he can come up with a new identity and steal all their money. Okay? So Gabe, what do I need to do to keep you from seeing all those packets and Social Security numbers that are traveling between the internets? You're absolutely right. And what do we call that? Yes? No, not for these purposes. There's another name. We covered it in earlier chapters. Give me a hint. We have 2 people, 3 people. Quinn. Encryption. How do you encrypt packets through the internet or between networks? What's it called? Yes, Austin. VPN. Very good. That's your last question for today. VPN. You did a fine job. VPN between the two. But we're not even gonna try to follow those concepts. We're just gonna pretend that the internets don't exist. And instead, what we're going to do is we're going to create another network down here with another router that's going to another private network with a switch that's going out to another PC and another server. And all of these devices, all of those devices need IP addresses and subnet mask and gateways. Okay, now I'm going to jump ahead. Let's say, what?
Yeah, I used to know some people who use VPNs for Xbox content.
We're not talking about VPN right now, so hold that question until break, we'll come back to it. Right now, I want you to concentrate on what we're doing here, and that is, this side, the Walmart network, is using a network of 192.168.7.0, okay? This is some other corporate office that's using a network of 172.16.0.0. This network over here is using 10.0.0.0 because it's got lots of hosts, but it only needs one network. Okay? If this PC here on the right side wants to speak to this PC here, I want you to talk me through the process. It's going to create a packet that it wants to send to this PC down here. That packet is going to have two things. Let's say, first of all, that this PC's IP address is 172.16.4.3. It meets the criteria, 172.16.0.0. So it's on that network. It has a subnet mask of 255.255.0.0, and it's going to have a gateway out there. Okay? What's the IP address of this PC here? What's the IP address going to be for the gateway? Yes? It's going to be the IP address of this router, right? That's its default gateway. Could be anything. 172.16.0.1. How's that? Okay? With the same subnet mask. All right. Now, what I want you to think about is, if this PC wants to send a packet to this PC with a 172.16, there's a couple things that it can do. First of all, in order to be able to see that, by the way, give me an IP address. Let's make this a little bit easier. So I've got the PC, I'm just drawing it so there's a lot less stuff. Then I've got a router. Then I've got another router over here. Then I've got a network. Let's just say it's one PC. Then I've got a router down here. And then the PC that we've been talking about. All right? And this network over here on this side, give me an IP address for this PC right here. That was on the 10 network. Michael Feast, give me an IP address for it.
10.0.0.
Got what? Okay, give me a subnet mask. Okay, give me a gateway. That's zero. What? Okay? Where do I assign that IP address? Wait, stop. Jill, where this 10.0.0.2 is the gateway, what would that also be the IP address of? Yes. So I assign that IP address here, 10.0.0.2. What's its subnet mask, Jill? Yep, subnet mask, 8-bit subnet mask. All right, so now, if that's the IP address, that's the gateway, 10.0.0.2, which is this IP address, and this PC, give me this PC's IP address, which was on the 172 network. Christopher, give me the IP address for that PC.
172.16.8.2.
8.2. Subnet mask, 255.255.
That's it.
Very good. And its gateway is going to be the IP address of what? The router above it. So we're going to assign that as 172.16.8.1. Has to be on the same network, right? All right, so that means this guy's IP address is 172.16.8.1 with a subnet mask of 255.255, And the gateway, what's the gateway of this guy gonna be? Miguel, this router's interface, what's the gateway gonna be? It's gonna be the IP address of this. Okay, it's gonna be the IP address of this. All right, now, if this PC over here wants to send a packet to this PC here, it's gonna have a source address and a what address, Brittany? The packet is gonna have, this is a packet, it's gonna have a source address of what? If this PC, okay, stop the camera, come back to that.